Now let's take a look at what proportion of the time we can expect to get each of these types of errors. Starting with a type 1 error, what proportion of the time will this happen? Let's think about why we would get a false alarm. We're obligated to concur with whatever our sample tells us about the world, and the only time we'll reject the null hypothesis is if we get a sample that lands us in the critical region. Remember, the critical region is the area of the sampling distribution that we define based on our alpha level. Before we even do the study, we define what region of the sampling distribution would lead us to reject the null hypothesis. And remember, we set alpha. Alpha is a level that we decide before doing the study. So if we'll only reject the null hypothesis when we get a sample in the critical region, and the critical region is defined by alpha, then the probability of a type 1 error, assuming the null hypothesis is true, is simply alpha. If we look at the distribution of sample means, if the null hypothesis is true, we can see graphically why this is the case. We'll only reject the null hypothesis if we get a sample in that critical region, and that critical region is exactly 0.05 of the sampling distribution when we're using an alpha of 0.05. So, our type 1 error rate is under our control. We're stating that if the null is true, we are okay with a false alarm rate of alpha. Now, we have to be a little specific here when we talk about the probability of these errors, because the probability of an error is conditional on the state of the world. That is, the probability of a false alarm has a different probability if the null is true than if the null is false. So let's talk a little bit more specifically about the probability of a type 1 error. Certainly, we already saw that a type 1 error will happen with a proportion of alpha if the null hypothesis is true. But if the null hypothesis is false, if H1 is true, if there really is some effect in the world, what proportion of the time could we false alarm? I hope you can see that the probability of a type 1 error, if the alternative hypothesis is true, is really 0 or undefined. There is no chance we can false alarm if there is really an effect. Said differently, there's no chance that the beeping of your fire alarm could be a false alarm if your house is burning down. When it beeps, if there's a fire, well, that's a correct rejection of the null hypothesis. That's what you hope it will do. So a type 1 error only exists if we're in a world where the null hypothesis is true. Now let's pause for just 1 second and talk about notation. Instead of using the word if, I'm going to write this out as the conditional probability. And this literally reads the same way. The probability of a type 1 error given or if the null hypothesis is true is equal to alpha. And the probability of a type 1 error if or given H1 is true is equal to 0 or simply undefined. So a conditional probability is an important idea. It is a statement about a probability given something else being true in the world. And notice that we can't talk about these errors without talking about it conditional on the state of the world. So going back, the probability of a type 1 error is only defined if the null hypothesis is true. And if the null hypothesis is true, the probability we will false alarm is exactly equal to alpha. Now what about a type 2 error? Well, I already told you this was called a beta error, so you might guess that the probability is beta. And just like we saw before, the probability of a type 2 error is conditional on the state of the world. There's no probability of making a type 2 error a miss if the null hypothesis is true. But if the null hypothesis is false, that is, the alternative hypothesis is true, the probability we make a type 2 error is equal to beta. Now again, remember that these errors are conditional on the state of the world. We can't make a type 1 error if there is an effect. And we can't make a type 2 error if there isn't an effect. So, we always have to talk about the probability of errors as conditional upon the state of the world.